is Jasmine, and I want to talk about a baseline approach to seabird susceptibility today. A little bit of background. We've known for a long time that oil spills affect seabirds in a lot of different ways. For example, it can coat their feathers and disrupt their waterproofing. It can affect their ability to regulate their temperature. They can ingest it, and it has toxic effects on various organs, and it can disrupt their reproduction by affecting their egg output. So a lot of different ways. We also know that how seabirds respond to oil varies by species, in large part just due to the fact that different species tend to have different traits. So maybe a species that dives deeper under the water or tends to be further offshore, it has been hypothesized might be more susceptible to oiling. And being able to identify which species are the most sensitive could have both scientific and management benefits. For example, if you're able to figure out which ones are the most susceptible, maybe you could avoid harming those species by avoiding those areas when you're planning where to do oil work. And or, after a spill does occur, we could target the species that are both susceptible and rare to be rehabilitated. So there could be a lot of different benefits. Species like common murre, which is shown here, are often held up as this poster child of an at-risk species. This is just because murre carcasses often show up in very large numbers on the beach after a spill occurs. What we were really wondering in my lab was, is this because common murres are actually more vulnerable, or is it just that they're a more common species? So for that area and for that time of year, we would have expected them to show up anyway. Our approach to kind of answering this general question is we want to compare oil spill carcass encounter rates to baseline data. So encounter rates just meaning how many carcasses we find washed up on the beach, so we can compare to that same area and that same time of year to see if what we see during a spill is really that unusual. Here we have the coastal observation and seabird survey team to serve as our baseline. This is a about 20-year citizen science data set in which volunteers go out and survey their local beach on a monthly basis. They go out, take photos of any seabird carcasses they find, they measure them, they identify them down to species when they can, and they send all that data to us at UW, where we verify the data, verify the species, etc. So we have this really nice long-term, broad extent beach bird data set we can use to compare. We're using this data set to compare against data from 2 oil spills, one of which occurred in the summer and one of which occurred in the winter. So that lets us do a little bit of compare and contrast for seasonal differences. Our 2 main questions are, how similar are oil spill years to other years in terms of species composition, and are some species especially sensitive or insensitive to oil spills, and if so, which? Here's a little bit about the data from the 2 spills and from our coast data set that we're using for comparison. So the 2 spills are the Nestucca and the Tenyu-Maru spills. For the Nestucca spill, it occurred in December of 1988. About 13,000 seabird carcasses were found. This is the latitude range of where the coastline was affected by the spill. And you also see here which part of the coast data set we sort of sampled from to use as a comparison. We use a 45-day window centered on the day that the spill occurred. So in this case, the 22nd of December, and then a 45-day window around that. We used the years 2002 to 2018, and that resulted in us having 11,000 birds for comparison. For the Tenyu-Maru, This spill occurred in summer of 1991. About 4,000 carcasses were found. Here's the latitude range, and I'll show a map to give you a little bit of a better idea in just a second. And here's the coast data set. So we used, again, centered on the day of the spill, and then a 45-day window around it. Years 2002 to 2018, once again, and that resulted in about 4,000 birds we could use for comparison. Next, I'm showing you the location where this research occurred. So, first of all, the red dots here, these little dots, are locations where we have coast survey data. So each one of those is a beach where a surveyor goes out monthly and collects data. We also have in the yellow square the Tenyo-Maru origin, so sort of off the northwest coast here of Washington. And we have the Nestucca origin, which is a little bit further down, kind of midway between Washington and Oregon. Finally, we have the extent of the coast data that I sampled to use for our comparison for each of the spills. So Tenyo-Maru, all the beaches within this range were used for comparison. Nestucca, I used this larger range because a larger area was affected. Okay. Next, I want to talk just a little bit about what species are involved here. We used all species that were in the spill and the coast data set, excluding land birds, shorebirds, and very rare birds. And that left us with still kind of a really nice variety of species from different taxonomic groups, have a range of different traits. And we ran all of our analyses from here on out for the lowest taxonomic group possible. What that means is that for the Nestucca spill, oftentimes they just kind of reported data for a large group. For example, maybe scoters was all kind of lumped together. They weren't able to identify all the carcasses as species. And that was true for a large percentage of birds in the Nestucca spill. For that reason, we ran the Nestucca data at a higher level than we did for the Tenyo-Maru. For the Tenyo-Maru, we were able to run all of these as individual species. We wanted to be able to compare the two, though, so we ran the Tenyo-Maru data for the group level as well, just to be able to compare it to the Nestucca. So to recap, Tenyo-Maru ran at the species and group level, Nestucca just at the group level. Now I want to walk you through these figures here. So on the left-hand side is data for Tenyo-Maru. On the right-hand side is data for the Nestucca. And we have both a zoomed out version up top and a zoomed in version below. The main thing to kind of take away from these figures here is really just that there is a difference between the baseline and spill. So for example, common mers are highly elevated in the spill even compared to the baseline versus something like the sooty shearwater here, where it is highly elevated in the baseline versus the spill. So we do see some interesting patterns just from this raw data. So here's our first question. Are oil spill years different from other years? And to tackle this question, we used principal coordinates analysis, so an ordination technique, and cluster analysis. Really, both just different ways of getting at this, how similar are oil spill years to other years? Are they within the normal year-to-year variation, or are they something really unusual? And here's what we found. So up top, you see Tenyo-Maru ran at the spill, or at the species level. In the middle, you see Tenyo-Maru ran at the group level. And on the bottom, you see Nestucca at the group level. A few interesting things to see here. First of all, the spill years are in red, and all the black dots are baseline years that are from the coast data set. And you can see that the variation in years with regards to the oil spill is really sort of in a MER direction, not full MAR direction, was kind of a general pattern that we took out of this. So variation in MERS and full MARS is really driving a lot of the variation in our spill years. Also, Maybe more interesting key takeaway, spill years are at the edge of their clusters, but they're not off on their own for the most part. So up here, it's in this kind of bigger cluster at the edge, but it's not in its own group. Same at the group level. For the Niseka, it is in its own little group, but it's really kind of a part almost of this larger group. So kind of main takeaway, spill years are weird, but they're not that weird. There's other years in the baseline that are pretty much just as weird. Maybe years that had really unusual weather events, El Nino, something to that effect. So there are other years that are also weird in the same or similar ways that spills are. Moving on to question 2, are some species more or less sensitive to oil spills than others? Here's how we tackled that. We came up with this new sort of technique wherein we plotted the proportion that each species made up during the spill against the proportion in the coast baseline. And I made this kind of simplified diagram to walk you through what that looks like. So for an example species, it's between 0 and 100% of the carcasses in that data set. So maybe 75% of the birds were common murre, something to that effect. Then it would be around here. Then we have this middle line, something we've called the equivalence line, that represents where you would have exactly the same proportion between the oil and the coast data. For example, maybe right here, you have 80%, if you're exactly on the line, 80% of the carcasses in the oil and 80% in the coast baseline. If you're above that line, we would say that you are relatively, elevated during the oil data, and you might be relatively susceptible to oil. If you're below that line, you're relatively less susceptible. You are relatively elevated in the baseline data. Another thing to point out is that for the oil spill data, we just have a single value because the oil spill only occurred once, thankfully. Whereas for the baseline data, we have a mean represented by this dot and a bootstrap 95% confidence interval. And that allows us to take into account the fact that there is this variation in the baseline data. Okay, here's what we actually found. There's a lot going on here, so I'll walk you through it. The top row is Tenyo-Maru at the species level. The middle is Tenyo-Maru at the group level. And the bottom is Niseka at the group level. On the left-hand side, we have the zoomed out version, and on the right-hand side, we have the zoomed in version. You might notice a couple different things here. The only species that was found to be really highly elevated during the spill, highly vulnerable, was common murres. And that was true at the species level and at the group level for the Tenyo-Maru, and then Niseka for murres, which is just common murres. So there's this kind of pattern where, yes, they're highly vulnerable. A lot of other things are in this kind of on the line or a little vulnerable or relatively less vulnerable space down here. Some other patterns, things seem to be phylogenetically conserved, so species that are highly related seem to be grouped together. For example, these red and orange taxa are the alcids, and they tend to kind of be in this relatively more susceptible space. On the other hand, the procelariids, which are these dark blue species, and loons and cormorants are all in this relatively unsusceptible space. So you can see these kind of groupings by family or by group. There are some differences between the summer and winter spill. Just as a for instance, scoters were kind of on the line for the Tenyo-Maru spill, meaning they were about the same in the spill versus the coast data, whereas for the Niseka, they were relatively elevated during the spill data. So kind of to wrap everything up, what we found broadly agrees with species that have been identified as vulnerable in the past. For example, common murres. We found that, just as is suggested by past research, there does seem to be some relationship, some genetic relationship where the more closely genetically related you are, the more likely you are to have similar susceptibility. But it clearly doesn't explain everything, because there is some variation within these groups as well. This method, kind of a downside, is that it can only be used where appropriate baseline data is available, so on the order of a couple decades of data, and that's pretty rare. But where this data is available, it can be extended to spills that occurred in other places or in other times of year. Ultimately, with the hope that it could be used by management to help protect seabirds that are most vulnerable to spills. Thank you to the audience and to our sponsors.